Hey guys, welcome back. Now in the last video we have downloaded the dataset from the Dropbox, and after we downloaded the dataset we have unzipped it and we have imported necessary libraries. In our case we have just imported OS, SHUTIL and the NumPy library. Now along with that, what we have done in last session is we have created our own dataset. That means we have split the dataset into one part. For now what we have done is, we have said we are going to make use of training data, and using that training data I'm going to create into three separate parts. Now in order to do that, I have mentioned that first I'll extract the data. So if you look at it, currently all my data are present inside my subfolder of training set. So if I expand my training set over here, I'm having the images of cats and dogs. So from this training set we are going to split into three parts, that is train, test and validate. Now to do that we are actually making use of OS library. So this is going to create some root directory. I'm going to put all our data in the root directory, which is called as in my current directory I'm creating a folder called data directory. So inside this I'm going to put everything. So if you look at it, in my data directory I'm actually having three subfolders: test, train and valid. And what I'm going to do is I'm just going to use all the data which is in my training set, get 70% out of it and I'll send it inside my training data, and 15% into my test data, and another 15% to the validation data. So what we have done in last session is, we have extracted 70% of the data. Now once we extract the 70% of the data, let's do one thing. Let's count the number of images that we have inside our directory. Now let's assume I'll run this code. I'll just run this code to measure as how many number of images that we have over here after we have done this activity of removal. So now instead of dir, I'll just say cats as an example. So I'm just having left out with 1201 images. So if I'm trying to extract the images, so what it actually means is, see, if you look at my previous code, I have actually removed it once I have separated my data set. So what I should be doing is, when I'm specifying this for loop again, I have to mention it like this. So I'll say using the data in the training directory, and I'll have to extract 50% of it. Because I have already extracted 70% out of it. So whatever the value that is left over there in my training directory, those are all the 30% of the data. Now in that 30% of the data, I want to get 15%. So it will be a 50% of the existing data. Now I'm extracting it and I'm sending it over here. So this would extract 50% of the remaining data into my test directory. So here I mentioned destination as test directory, and I'm getting everything guys. I'll just execute this. So this would extract 50% of my remaining previous data back into my test directory. Now if I simply copy and find the length, so if I find the length, I am now left out with 601 images. Now what I'll be doing is, I'll use this complete 601 images into my validation data. So while specifying the number, I'll just remove this into 0.50, and I'll just use everything that is present over there. Now I don't have to use the int as well, because length will obviously is going to return me the integers. So now I'll just execute this. So I'll have to mention it as valid. Great. So what I have done right now is, I have moved all the images that are present inside my original training data. So this is my original training set. Now if I expand this, see, currently it is empty. The reason because I have moved all the data which was actually present in this folder into my test, train and valid. So we can verify the same. I'll expand my train. See, I have two subfolders, cats and dogs. So it's taking a while to load because there are so many images. See, you can see the various images of cats. I'll do one thing. I'll just download an example image of cat. So if I download an example image of cat, so this is how an example image of cat looks like. Okay, so we are using this collection of cats and dogs, and we are going to build the classifier on top of it. Now we can explore the test directory as well. If I expand my test directory, see, I will be having the images of cats and dogs over here as well. Okay, so what we have done right now is we have moved all the data set into 3 subfolders: test, train, and validation data. Now let's do one thing. Let's see how the data is distributed into all of these subdirectories. So in order to do that, what I'll do is, let me check if I already have my root directory defined. Yes. So this is what my root directory looks like. Okay, so my root directory is my data directory. Let's do one thing. I'll write a code that would look like this, and then I'm going to explain. I'm going to create a X and Y as a blank Python list. Now after this, I'm going to write something like this. I'll say for folder which is present inside my directory of root directory. Okay, and then I'm going to say that I'm going to create a dictionary. I'll call it as D, and in this dictionary I'll create a key as cats, and I'm going to initialize to be equal to 0, and I'll create one more thing called dogs, and I'll initialize to be equal to 0. Then I'm going to create as class underscore dir, and I'm going to say that os dot path dot join, and I'm going to say root directory comma folder. Okay, and then I'm going to say that, okay, for class I'll say cls in os dot list directory of class underscore directory, and I'm going to mention that images is equal to os dot path dot join, and I'm going to get class dir comma class. Okay, now after this I'm going to say that, okay, for dcls is equal to length os dot list directory of images. Okay, x dot append, and I'm going to append dcls, and I'll also do the same. So I'll also say y dot append, and I'm going to append the folder name. Okay, so I'm using my F formatting, guys. So folder, and I'll write as class. Okay, let's invert it. I'll say y dot append values, and for x I'm going to store the folder names. So let me just execute this, and then I'll explain what is happening in this code. Now here in this code, to begin with, I have created a blank Python list called x and y. Now after I created this x and y as a blank Python list, I'm going through every directory which is present inside my root directory. So this is my root directory, and I'm going through every folders that are present inside this root directory. And inside that I have defined a dictionary as D. Okay, and I have mentioned that, okay, for each folder, let's say I'm going inside my test folder. So in the first iteration, I'll have the folder is equal to test. So that is the name that it's going to get. And then I'm saying as, okay, for class in os.list directory. Now to make it very easier for you to understand, I'll copy this code and I'll explain in my OneNote. That will be easier for you to understand, guys. So I have mentioned that for folder in os.list directory, that means each time when I'm running this iteration, this folder will get the folder name of either test, train, or valid. Let's assume it takes the folder is equal to test in the first iteration. Now once it gets the folder is equal to test, I'm saying as, okay, create a Python dictionary which is called as D, and the keys are cats and dogs, and I'm initializing the value to be equal to 0. Now on top of this, I'm getting class directory and I'm joining this root directory. The root directory is data.directory. I'm joining this. That means I'm going inside a subfolder of this root directory. That means I'm going inside this test folder because that is what is present in this first iteration. And I'm storing that complete path like data directory and the test inside my class directory variable. Now after this, I'm going inside the subdirectories of this class directory. That means I'll highlight it. So I'm now going inside this test folder. So the subdirectories are cats and dogs. So cats and dogs. Now in first iteration, CLS will take the cat. Okay. Now I'm checking as how many number of cats images are present in this subfolder of cats. In order to do that, first, I'm getting that complete path by saying as, okay, join my test with this cat subfolder name. And then I'm calling the len on top of it. So this is going to give me the number of images that contains the images of cat in this test subdirectory. Which means that, okay, in my test folder, how many images of cat that I'm having. And once I do that, I'm appending that value into my YPython list, and I'm also storing inside my original Python dictionary, guys. And then in my X, I'm just storing the folder name. That is the in this scenario, the folder is the test, and test underscore the class that is cat, and that is what will be stored in the first iteration. And then it goes ahead and for CLS it picks dogs, and it does the similar activity and checks how many images of dogs that I'm having over here and adds it in my Python dictionary and get that value in y.append. Okay, and it also appends that folder as well as its class name to this X as well. Now once I've done that, I'll go up and this time I'll pick the next directory, that is train. So once I pick the train, I'll go inside the train. I'll have another subfolders of cats and dogs. In the same way, I'll see how many number of images of cats and dogs are present. I'll get that number and I'll proceed ahead with the validation data, that is valid folder as well. Now in this way, I'm iterating over every subfolder inside another folder. And in final, I'm checking as how many number of images that I'm having with me. Now once that is done, I can create a visualization to see as, okay, how I have the data that is present with me. So if I want to create a visualization, obviously I'll have to import cborn library. I'll use cborn, guys. Okay, and I'll say sns.set_style, and I'll use the style of dark grid. It will be nice to see. And I'll say import matplotlib.pyplot as plt, and I'm going to say plt.figure, and I'm going to set my fig size to be equal to, let's say, 12,5. Okay, and I'm going to create a cborn object, so sns.barplot, and I'll say x, y, and I'm going to set the title. So title is data distribution. And finally, I'm going to show my image, plt.show. So this is going to give me the visualization as how many number of images that I'm having in my training set, as well as my test set, as well as my validation set. So 70% of data is in my training set, 15% each in my test as well as my validation set. Okay, so now that we have done all the activity, in the next video, let's see and let's print some of the sample images that we have for cats and dogs, and then take our analysis further. So I'll see you next time, guys.